In this video, we're going to talk about a couple other organometallic reagents, and in this case specifically coupling reagents, where we're going to take two carbon groups and couple or bring them together to make one. So the first example we're going to look at are organocopper reactions. And the first thing we're actually going to do is add lithium, which might seem strange. But if we start with an alkyl halide and add in 2 moles of lithium metal, and here propane is a very common solvent, again, aprotic. What happens is the lithium will replace the halogen. You'll also get lithium X, whatever your halogen was. Okay. Now again, we've got partial negative, partial positive structure. So we have kind of a carbanion. It's not quite as strong as Grignard, but we do. So again, we have a nucleophile basic molecule. This then is what we're going to use to make a Gilman reagent. Which is an organocopper molecule. So we need 2 molecules of our new organolithium molecule from previous reaction. We're going to react that with copper iodide. This needs to be an ether. And what happens is we're going to have both of the R groups, right? We have 2 R groups here with the copper and the lithium. And this is a salt. We do have full negative positive charge. Byproduct is going to be lithium iodide. So the second lithium and the iodide here. Okay. What happens now is I can take this organocopper reagent, the Gilman reagent, react it with an alkyl halide. So it's not necessarily the alkyl halide that I started with originally here, but some alkyl halide. Here this cannot be fluoride, but it can be chlorine, bromine, iodine. I need ether. I'm going to cool it down. And what happens is the new alkyl group plus one of the original alkyl groups are going to couple or form a new carbon-carbon bond. Byproducts here, we have another lithium iodide as well as a copper-carbon bond. Okay, so the second R group byproduct. But the key is that I'm making a new carbon-carbon bond. And this can be key when you're doing synthesis reactions. Now this is going to work on allylic and vanillic halides as well as any alkyl halides. So as an example, I want to synthesize this molecule from this vanillic halide. So the halide is actually on the double bond, so that makes it vanillic. And then my second alkyl halide, will be this. So let's see if we can see our pieces. We have 2, 3, 4, 5. 2, 3, 4, 5. So there's the carbons from the vanillic halide. Then I have 2, 3, 4, 2, 3, 4. So there's the carbons from the alkyl halide, which means this is my new carbon-carbon bond that I'm going to form. So I need to make a new bond between this carbon and this carbon. So when deciding what's going to be my organolithium reagent turned into Gilman reagent versus the halide that is just added in that Gilman reaction, we're going to use the vanillic, or if it was allylic, as the added halide, and use the alkyl halide to make the Gilman reagent itself. So your Gilman reagent, you need alkyl halide. What you then add your Gilman reagent to could be allylic, vanillic, or just another alkyl halide. So we're going to start with our alkyl halide. We first need to do the lithium reaction. So we're going to get the alkyl portion with the lithium added in. That then is going to be converted into the Gilman reagent. We're actually going to need 2 of those, along with copper iodide and ether. And what we're going to get is two of the R groups attached to the copper lithium combination as our Gilman. Now I'm going to add in the allylic, in this case vanillic halide. And this is where I get the coupling between this end carbon of my Gilman and the location of the halide in the other reagent. And that is then going to lead me to my product. So I'm just going to draw my arrow back up here. We need ether and that's 0 degrees to make this happen. So again, you're going to take your alkyl halide half, convert it into your lithium molecule, your alkyl lithium. Then you add your copper in the form of copper iodide to get your Gilman reagent. Then that Gilman you can mix with whatever other halides you happen to have, whether it's alkyl, vanillic, allylic, whatever it might be, and you can form your new carbon-carbon bond. Another example of an organometallic coupling reaction that we want to be familiar with is the Suzuki-Miura reaction. So again, we're going to make a new carbon-carbon bond. Here, this one's most typically used with aromatic or vanillic halides. It is not going to work with alkyl halides. So here you need to be coupling stuff with double bonds, essentially. So aromatic rings coupled together, vanillic positions coupled together to form dienes. This is preferred over the previous reaction, the Gilman reagent, if possible, because you're using catalytic amounts of the metal. For Gilman, you're using straight up molar ratios. Here, the palladium that is used in a catalytic quantity, so it's a much cheaper way of doing it. But again, it's only going to work if you don't have alkyl halides involved. So the reagents that we're going to be using, we're going to have whatever our R group is. Again, that needs to be aromatic, so benzene ring typically, or vanillic, so your halogen is on the double bond. This is going to be attached to a boron hydroxide group. So if we want to see what that looks like in a specific example, if I have benzene, it's going to be attached to boron, which is attached to 2 hydroxide groups. So again, R group, aromatic or vanillic. So in this case, my R group specific example is the benzene ring. So let's say I want to react that with a second benzene. I'm actually going to use a toluene, so add a methyl group, and I want my coupling to be para to that methyl group, so my iodine is going to be over there. So my new bond is going to be between the carbon that has the boron and the carbon that has the halide. The additional reagents, the catalytic amount that I mentioned earlier, we need palladium, and that has a phosphorus triphenyl group. We're also going to need some copper carbonate, and this all happens in THF. And we're not going to talk about the mechanism of this one, but you want to be able to produce products when you have these reagents, or know these are the reagents used if you're given reactants and products. So I have my benzene now attached to the second benzene, and the attachment is para to that methyl group. So here is the new bond that is formed. So again, if you want to make a carbon-carbon bond between two benzene rings or two vinylic positions, this is your best choice.